time for a review on quadrilaterals. This first set is really easy. All we're going to do is we're going to take the number of sides, subtract 2 from it, and multiply by 180. So this one right here, 48 gone, means you're doing 46 times 180, which should give you 8,280 degrees. Number 2 will be 60 times 180, and that's 10,800 degrees. And then last one, 88 gone, means 86 times 180, which means 15,480 degrees. That's pretty easy to do. Now, 4 through 6, where we have exterior angles. Anytime you see that word exterior, that means 360 degrees, period. We don't multiply, we don't divide, we don't do anything. We just say 360 degrees. Alright, and with these ones with the regular polygon, you start the exact same way as you did in 1 through 3. So 22 gone means I'm going to do 20 times 180. But then what I have to do is I need to divide by how many sides or angles I have. So divide by that new number, 22. So that means I should get as an answer for that one about 163.6 degrees. Alright, so same thing. 11 minus 2 is 9, so that's what we multiply by 180. And then divide by my total number, 11. So that will give me an answer of 147.3-ish degrees. And then for 73 gone, that means 71 times 180 for the total amount. Divide by the 73 total angles means that each angle should be 175.1 degrees. Alright, now on this next problem, all we're looking is to find the value of x. All we're looking at is the interior-exterior angle. So this is a quadrilateral interior angle. That means I'm adding everything up to 360 on the inside of a quadrilateral. Add everything up. Well, I have 9x plus 8x gives me 17x's. Add another 8x gives me 23. Excuse me. 25x, I apologize. And then 5x more gives me 30x. And then here, negative 3 plus 2 plus 1 means just plus 0. So 30x equals 360. To solve that, I'll divide both sides by 30, and I should get x is equal to 12 for that problem. Now, for number 11, I'm going to add everything up again because I have interior angles, plus 7x minus 25, plus 4x minus 5. This is the inside of a triangle. A triangle adds up to 180. So, how many x's do I have? I have 21 x's when I have 10x, 7x, and 4x. And for the rest, I have minus 25 and minus 5 means minus 30 to equal 180. I'm going to add 30 to both sides, so 21x equals 210, which means that x equals 10 for my answer. Now, number 12, this is one where you'll make your most mistakes. These are exterior angles, and exterior angles always add up to 360 degrees. So, again, let's figure out how much we have when we add all this up. I have a 2x, I get it, let's get rid of it, plus a 4x, plus another 4x, plus an x plus 6, plus a 3x minus 20, plus an 8x to equal 360. When I add all those up, I should have 4, 6, 10, 11, 14, 22 x's. And I should have, for my unit values, I should have a 6 and a minus 20 means minus 14 equals 360. I should have 22x now equals 374. When I do that division, I should get that x is equal to 17 for my answer. Now this last one, again, adding everything up. What do I add these ones up to though? I have a pentagon, 5 sides. That means I need to do 5 minus 2 is 3 times 180 for my total interior angles. That adds up to 540. So something to equal 540, I have 3, 4, 5, 10, 14, 15 x's. And as for my units, I have plus 1, minus 9, minus 7. So that should be a minus 15. 15x minus 15 to equal 540. That means 15x equals 555, which means x should equal 37 for my answer. Now, the big page, the one that you're going to have the most issues with, is with these identifications, so multiple choice. Let's start with these. Anytime that we have words, make sure we use our chart. If you forget what your chart is, see if I can draw it here for you real quick so you can see. Your chart that we're going to look at, remember we start with the quadrilateral. The quadrilateral goes down to the trapezoid or the kite. Trapezoid goes straight down to the parallelogram. Trapezoid goes straight down to parallelogram. Parallelogram goes to rhombus or rectangle. which both of them feed down into the square. And also don't forget kite goes down to rhombus as well. So to start with this, the first one says diagonals are congruent. Diagonals being congruent happens here at the rectangle. So when we have ones with the words, rectangle has congruent diagonals. So that should be our first answer is D. What else would have congruent diagonals? What else could be called a rectangle? The only thing that could be is the square. The square is E. So D and E are my answers. 15, perpendicular diagonals. Perpendicular diagonals happen at the kite. What else can be called a kite? A rhombus and a square. So I have B for my kite, but I also want a rhombus and a square as my answers. 16, diagonals that bisect each other is a parallelogram. So my parallelogram is where I'll start with G, and then what could also be called a parallelogram? Rectangle and rhombus, and therefore also a square. So rectangle, rhombus, and square are also good answers. Number 17, diagonals are both congruent and perpendicular. Congruent happens at rectangle, perpendicular has at kite. What thing is both a rectangle and a kite? Well, that's only the square. That's the only thing that could possibly happen, so E. Number 18, two pairs of parallel sides. Well, that happens in a parallelogram, so that's my first answer. And again, what else can you call a parallelogram? Rectangle, rhombus, and square. So rectangle, rhombus, and square. Notice 16 and 18 were both parallelograms to start. That's why they ended up with the same answer. And number 19, four congruent sides. That happens in a rhombus. And what else is a rhombus? We can also call a square as a special rhombus. So C and E for number 19. Now, number 20, when we get into these pictures, same thing, we're going to start with what is the most specific name that we can give to that. We can call that a parallelogram because it has two pairs of parallel sides. Now, what else can we call it? Well, it has at least one pair of parallel sides, so I can go up and call it a trapezoid, which is F. And then because of that, I can also call this a quadrilateral in general, just if it didn't have any special qualities, but it's still a quadrilateral. So for the pictures, you're going to go as most specific as you can, then work your way back up. Number 21, a lot of you want to call this a square. However, we do not have right angle markings, so we cannot call this a square. The only thing we have are four congruent sides. That makes it a rhombus. What else could we then call it? Well, anything above it shares the name with the rhombus. If it's a rhombus, it's also a parallelogram. It's also a kite. It's also a trapezoid. So it's also a parallelogram, G. It's also a kite, which is D. It's also a trapezoid, which is F. And it's also a quadrilateral, which is A. All these with pictures, you should have A as one of your answers for sure. So we'll just get that down right now. You should always have at least a quadrilateral for each name for a picture. Number 22 kind of looks like a kite. However, we don't have a second pair of sides that we know for a fact are congruent. So because of that, the only answer I can guarantee is just saying A for quadrilateral. I can't say anything else for sure, so I'm just going to leave it just as A. After that, 23, we have four congruent angles, and we have sides that are not all congruent. So that means that all we can say is a rectangle for sure. So we'll start with rectangle, then work our way up. Rectangle to parallelogram, parallelogram to trapezoid, trapezoid to quadrilateral like we did before. Alright, so let's get this out of the way and look at the next couple that we have here. We have our next set for 24 through 27. What we're going to look at here. 24 is the same one that we had as number 21, where we want to look at, we have four sides that are congruent. Four sides being congruent is a rhombus. That makes it C. A rhombus is also a parallelogram. It's also a kite, trapezoid, and quadrilateral. So we also want to say parallelogram G, kite B, and trapezoid F, and quadrilateral A. 25 kind of looks like a trapezoid. However, we don't have any parallel lines being marked, so I can't say it for a fact. So all I have, again, for number 25, all I have for a fact is just A, quadrilateral. Number 26 is going to be, this one will be a trapezoid because I do have my two pairs of parallel sides. So I will have a trapezoid, and then of course it is still a quadrilateral, so F and A. That should be for number 26, not 25. And then my last one, number 27, This is where I have two pairs of congruent sides right next to each other. That makes it a kite. So B, and then of course quadrilateral as well. So B and A. All right, coming down the home stretch, number 28. To make this a parallelogram, first we're looking at X. Keep that in mind. X is here with sides. Sides in a parallelogram must be the same, so I'm going to set them equal to each other. So 12x minus 8 will equal 8x plus 22. And then I'm just solving for x for this. So I should get 4x is equal to 30, which means x is equal to 7.5. The next problem tells us the value of y is what they want to know. So from that, if they want to know y, well, what is y? Y are these angles. These angles are right next to each other. Consecutive angles, remember it's like our same side interior angles, they must be supplementary. So that means since they're right next to each other, 3y plus 5 plus 9y minus 5 equals 180. So when I simplify this, it gives me 12y equals 180, which means that y will equal 15. Now, finding the value of z that makes this a rhombus. Again, where is z? Z is here as a side length. Z is a side. To be a rhombus, that means all sides would have to be the same. That means it would have to be the same as one of these two sides we already know. How do we find this actual value for them? Well, all we need to do is plug back in 7.5. So when I plug back in 7.5, you should get 82 as that value. So that means all I'm going to do now is set 82 as the side length is equal to 5z minus 3. So that means I add 3 to get 85 is equal to 5z. And when I do that division, I should get z is equal to 17. And then finally, diagonals of this quadrilateral, and we want them to be, we want to make it so it's a rectangle. Well, if that happens, the diagonals of a rectangle are perpendicular, not perpendicular, they are congruent. So that means that these two values should be the exact same if it's a rectangle. So I'm just going to set them equal again. 2w plus 4 equals 5w minus 14. Subtract 2w to give me 3w on each side, on this side. Add 4 will give me 18. 18 then divide by 3, and I should get my value of w is equal to 6 for that one. Alright, and the last page. All we're doing here is analyzing and classifying these quadrilaterals. So nice and easy to start. We need to find first the length of both AC and BD using the distance formula. Remember, the distance formula is subtract the x's and square them, subtract the y's and square them. For AC, if I subtract the x's, I'll get 4 minus 2 and square it. Subtract the y's, I should get 0 minus 6 and square it. So that means this is the square root of, this becomes 2 squared, which is 4. This becomes 6 squared, which is 36. So I should get the square root of 40. Let's see what I get for BD. Same thing, subtract the x's and square them. 6 minus 0 squared. Subtract the y's and square them. 4 minus 2 squared. So again, I get 36 for the first one, and 4 for the square root of 40. So diagonals are congruent. That means I definitely have a rectangle already. Now, looking at slopes, if I look at AC slope, and then BD slope. So with AC, for AC, I'm going to do subtract the y's on the top. So 6 minus 0. If I do 6 minus 0, that means I have to do 2 minus 4 on the bottom. 2 minus 4. 6 over negative 2, which gives me a negative 3 for that one. Remember, we're doing on mountains here that some of you like to make. Alright, for BD, same thing. Subtract the y's on top, 4 minus 2, and subtract the x's on the bottom. If I did 4 minus 2, I'll do 6 minus 0. And I should get 2 on the top, 6 on the bottom, which gives me a positive 1 over 3. So, look what happens. I have opposite sides, and one's the reciprocal of the other. That makes it also a rhombus because they're perpendicular diagonals. So rectangle and a rhombus, that means it's also got to be a square. That's how you want to set these up. And the last one, just make sure we have all this down pat. For these, finding the lengths of this, this should be number 35. We're going to have DT and OS, same thing. Figure out what those distances are. Then we're going to do a slope for DT, and we're going to do a slope for OS as well. Okay, let's start with distance again. For DT, so start with dt to do the distance. Subtract the x's in square, so 6 minus 1 squared, and then subtract the y's in square, 5 minus 1 squared. So I should have the square root of, this becomes 5 squared is 25, this becomes 4 squared is 16, so it's the square root of 41. Then for OS, all I'm going to do for OS is the same thing. 6 minus 1 squared plus 5 minus 1 squared. Same exact numbers, 25 and 16, so the square root of 41. So yet again, we have a rectangle because they are the same length. Finding the slopes, dt. Subtract the y's on top, 5 minus 1. Subtract the x's on the bottom, 6 minus 1. So I should get 4 over 5 as my slope. For OS, I should have subtracting on the top 5 minus 1. Subtracting on the bottom, if I did 5 minus 1, I should do 1 minus 6. So I have 4 on top, negative 5 on the bottom. So I have 4/5 for one, negative 4/5 for the other. They are opposite signs, but they are not reciprocal. So it is not a rhombus, which means it is not a square either. There you have it. Best of luck. You should be in good shape.